So this is our next exercise of our trigonometric identities. So in the second exercise, we have to eliminate these thetas. Here we have these two thetas. We have to eliminate these two thetas. So to get that, we have to convert this in terms of squares, because here we will be having our three identities, which is sin square theta plus cos square theta is equals to 1. Cosecant square theta minus cot square theta is equals to 1, and secant square theta minus tan square theta is equals to 1. These are the three identities we are going to use for this exercise. So only by using three identities we are going to solve this exercise. So first question here we have is x is equals to a cosecant theta and y is equals to b cot theta. First transpose this a and b to LHS side. We will get it as x by a is equals to cosecant theta and y by b is equals to cot theta. Now we have to apply square on both sides. That means we'll get it as x by a whole square is equals to cosecant square theta, and our next y by b whole square is equals to cot square theta. So here we'll be writing it as x square by a square is equals to cosecant square theta, and y square by b square is equals to cot square theta. And here we have this identity in terms of cosecant square and cot square. Now we have to use this. To get this, we need to have subtraction relation between them. So we have to subtract this, that is x square by a square minus y square by b square is equals to cosecant square theta minus cot square theta. And here in this place we'll replace this with 1. X square by a square minus y square by b square is equals to 1. This is our required answer without any theta values. Next, question number 2. Here we have this also we have to convert in terms of squares. Here we have two terms in RHS, so we'll leave it as it is. We'll apply square on both sides. That is, we'll get it as x square is equals to a cot theta plus b cosecant theta whole square, and repeat the same for second term, which is y square is equals to a cosecant theta plus b cot theta whole square, and this is in the form of a plus b whole square and a plus b whole square. Expand that in that form and we'll get it as x square is equals to a square cot square theta plus b square cosecant square theta plus 2ab cot theta and cosecant theta. And second term, y square is equals to a square cosecant square theta plus b square cot square theta plus 2ab cosecant theta minus into cot theta. And here the relation between cot and cosecant is with subtraction. So we'll subtract these two. We'll get it as x square minus y square. This complete y square equation we have to subtract it from x square. So LHS separate and RHS is also separate. We'll get it as a square cot square theta plus b square cosecant square theta plus 2ab cot theta into cosecant theta. First, all the terms remain same. This will change into minus. We will get it as minus a square cosecant square plus b square minus b square cot square theta minus 2ab cosecant theta into cot theta. So this plus and minus gets cancelled. Our remaining values are x square minus y square is equals to a square cot square theta plus b square cosecant square theta and minus a square cosecant square theta minus b square cot square theta. Here we have our identity cosecant square minus cot square. First, from these two terms, take a square as the common factor. We'll get it as a square of cot square theta minus cosecant square theta. And from these two terms, we can take out b square as the common. We will get it as cosecant square theta minus cot square theta. Whereas in this value we can directly replace our 1, whereas here we have inverse. Inverse means if you want, you can take out the minus sign as common. We'll get it as cosecant square theta minus cot square plus b times of, here I can replace this with 1, and here also we'll get it as a square of, this is 1 again, b square of 1 is b square, which can be written as b square minus a square. Therefore, x square minus y square is equals to b square minus a square. Next, question number 3, here we have, this is in terms of cube, but this cube is only for trigonometric functions, which is for secant and for tan. So first write this as x by a is equals to secant cube and y by b is equals to tan cube. And what we have to do in order to remove this 3? Here we have 3, and in the same way we have to get a square for this. So if we multiply this with 2 by 3, we'll get it as 1. So let's apply this 2 by 3 on both sides. Applying power 2 by 3 on both sides. Or you can do it in 2 steps also. We'll get it as x by a whole power of 2 by 3 is equals to secant cube of whole power of 2 by 3. And for second term, y by b whole power of 2 by 3 is equals to tan cube theta whole power of 2 by 3. This cube and the denominator gets cancelled. We'll be having x by a whole power of 2 by 3 is equals to secant square theta, and y by b whole power of 2 by 3 is equals to tan square theta. And what is the relation between secant square and minus tan square? Here we have minus. So let's subtract these two values. We will get it as x by a whole power of 2 by 3 minus y by b whole power of 2 by 3 is equals to secant square theta minus tan square theta. And here this we can replace with our identity, which is 1. We'll get it as x by a whole power of 2 by 3 minus y by b whole power of 2 by 3 is equals to 1. Next, question number 4. Here also we have to apply square on two equations. We'll get it as x by a cos theta plus y by b sin theta whole square is equals to 1 square, and x by a sin theta minus y by b cos theta whole square is equals to minus 1 whole square. Let's expand this in the form of a plus b whole square. We'll get it as a square, which is x square by a square cos square theta and y square by b square sin square theta, and plus 2ab of is equals to 1. 1 square is 1 only, and for the second term we'll get it as x square by a square sin square theta plus y square by b square cos square theta minus 2ab. Because it is a minus b whole square, we'll get it as a square plus b square minus 2ab, and minus 1 whole square is plus 1 only. And here we have our values in terms of sin square and cos square, and the relation between them is sum. So we have to add these two equations. So let's add these two. We'll get it as x square by a square cos square theta plus y square by b square sin square plus 2xy by ab cos theta into sin theta plus the second equation, which is x square by a square sin square theta plus y square by b square cos square theta minus 2xy by ab cos theta into sin theta. And here we have 1 plus 1, which is equals to 2. And here we have plus term and the minus term. We can cancel out that. And the remaining values are x square by a square cos square theta plus y square by b square sin square plus x square by a square sin square theta plus y square by b square cos square theta, and is equals to 2. And from these two terms we can take out our x square by a square as common. We'll get it as cos square theta plus sin square theta. And from these two terms we can take out y square by b square as common. We'll get it as sin square theta plus cos square theta. And we have our identity Sum of the squares of sine square plus cos square is equals to 1. We'll get it as x square by a square plus y square by b square is equals to 2. So question number 5, here also we have to apply square. So before that we have to transpose this value. We'll get it as x minus h is equals to a cos theta, and we'll transpose this a. We'll get it as x minus h by a is equals to cos theta. Same with this, y minus k is equals to b sin theta, and y minus k by b is equals to sin. And we know the relation between them is sin square theta plus cos square theta is equals to 1. So we'll be applying square on both sides. We'll get it as x minus h by a whole square is equals to cos square theta, and y minus k by b whole square is equals to sin square theta. And just we need to add this 2. We'll get it as x minus h by a whole square plus y minus k by b whole square is equals to sin square theta plus cos square theta. And here we have our identity, x minus h by a whole square plus y minus k by b whole square is equals to 1. So here our theta is removed. So next we have our question number 6. Here also we have to apply square on both sides. We'll get it as cos square a by cos square b is equals to m square, and do the same for the second, which is cos square a by sin square b is equals to n square. Now we have to add, because for sin and cos there we just have only one relation, which is an addition, so we have to add. We'll get it as n square plus n square is equals to cos square a by cos square b plus cos square a by sin square b. So here we have same numerator. Let's take it out as common. We'll get cos square a of 1 by cos square b plus 1 by sin square b. So here we have to take the LCM here. We'll get it as cos square a of sin square b plus cos square b by sin square b into cos square b. And here we have our identity, which is sin square b plus cos square b, which is equals to 1. So we'll get it as n square plus n square is equals to cos square a of 1 by sin square b into cos square b. Right? Next, if we observe here, we have cos square a by sin square b is equals to n square. We'll write this like cos square a by sin square b into again 1 by cos square b. Now we have to transpose this cos square b to the LHS side. We'll get it as n square plus n square of cos square b is equals to cos square a by sin square b. And here we have this value, which is equals to n square. Now let's replace this complete value with n square. We'll get it as n square plus n square of cos square b is equals to n square. Next, question number 7 we have, which are having three terms here, which is x, y and b, and we have to prove x square by a square plus y square by b square minus z square by c square. So here we need to have x by a, y by b and z by c. We'll write that in that form. We'll get x by a is equals to secant a into cos b. Let it be our first, and this y by b can be written as secant a into sin b. Let this be our second, and next third we can write it as z by c is equals to tan a. Let this be our third. And here we have x square by a square. That means we have to square and all the terms, and we have to write this in a specific manner that first and second should be added, and we have to subtract the square of third term from it. That means secant a cos b whole square, that is x square by a square plus y by y square by b square, which is secant a sin b whole square. This is our second term, which represents y square by b square. Next we have minus of z by c, that is z square by c square is nothing but tan square a. Now we'll expand this, that is a into b whole square is a square into b square. This we can write it as secant square a cos square b plus secant square a sin square b minus the tan square a remains same. And here we have secant square a as common. Let's take it out. Secant square a of cos square b plus sin square b minus tan square a. And here cos square b plus sin square b is our identity, which is secant square a of 1 minus tan square a. And secant square a into 1 is nothing but secant square a. And here we have our identity, which is secant square minus tan square is equals to 1. This is what we need to prove. This is our required RHS value.